Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak Nemani and this is Daily Quant with Deepak. Hi all, welcome back to day 35 of 100 days to CAT Quant series. In this video, we'll be discussing 5 questions from algebra. So if you come across a question on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. If you find this video useful, like the video, share this video with your friends who are preparing for CAT, and most importantly, for more videos of this kind, subscribe to this channel. And in case if you want to attempt these 5 questions as a test, you can log into our portal, the gurukul.org.in. The link is provided in the description below. All you need to do is you need to sign up and log in so that you can get access to our 100 days race to CAT course, in which there are 3 sections: Quant, LRDI and VRC. We will be uploading 100 tests in each section. So consider this to be your last mile of preparation. And if you are a serious CAT 25 aspirant, you cannot afford missing these tests. And without any further delay, let's get started with the first question. What is the highest integer value of x for which x cube minus 14x square plus 49x minus 36 less than 0? Now let's find the values or the roots of this polynomial, right? So first, whenever you come across polynomial of degree 3 or more than 3, first find the sum of all the coefficients of these terms. So 1 minus 14 is minus 13, minus 13 plus 49 is plus 36, plus 36 minus 36, 0. So this tells me that 1 is a root. So this should be divisible by x minus 1. Now let me divide this polynomial by x minus 1. So I need to multiply this with x square so that I'll be getting an x cube term here. So x square minus, sorry, x cube minus x square. Now on subtracting, these two will get cancelled. Now minus 14x square plus x square minus 13x square plus, bring this term 49x. Now with what should I multiply to get minus 13x square here? I need to multiply that with minus 13x. So you'll be having minus 13x square and plus 13x here. So again subtracting, this will become plus, this will be minus, these two will get cancelled. 49x minus 13x, 36x minus 36, right? So I need to multiply this with plus 36. So you'll be having 36x minus 36 here. On subtraction, these two will get cancelled, right? So I can write x cube minus 14x square plus 49x minus 36 as x minus 1 into x square minus 13x plus 36. Now let's factorize this. Now product of these two is 36 and sum is minus 13. So I can still factorize this as x minus 1 into, I will write this as x square. We need to find two numbers such that the product is the plus 36 and the sum is the minus 13, minus 4 and minus 9 plus 36. So I can write this as x minus 1 into x minus 4 into x minus 9. So I can factorize this as x minus 1 into x minus 4 into x minus 9. Now this should be less than 0, right? Now let me plot these values on the number line. So let's start with the smaller value 1, then we have 4, then we have 9. Now this is a number line, guys. Now for all the values greater than 9, this will be positive. Why? Because this will be positive, this will be positive, this will be positive. For all the values of x greater than 9, right, this will be positive. Now between 4 and 9, negative, right? Because if it is greater than 4, these two will be positive and this will be negative, right? So you'll be having negative values for x when x lie between 4 and 9, right? Now between 1 and 4, this will be positive because this is positive, these two are negatives. Negative into negative, that becomes positive, and when x is less than 1, you will be having negative value because all these three are negatives. Now we are asked to find the highest integer value of x for which this is strictly less than 0. So that should be less than 0 only. So this should be less than 9. Now what is the highest integer less than 9? 8. So the answer for this question should be 8. Now coming to the second question, given with log 4 is equal to 0.6, we are asked to find the value of log 5. right? Now log 4, I can write log 4 as log 2 square, which can be written as 2 log 2, right? Now 2 log 2 is given to be 0.6. Now the value of log 2 is 0.3. Now once we have log 2 is equal to 0.3, we can find the value of log 5. How? We know that the value of log 10 is equal to 1. Now let me write 10 as log 5 into 2. Now I can write this as log 5 plus log 2, and this is equal to 1, or log 5 is equal to 1 minus log 2, 1 minus 0.3, 0.7 should be the answer to this question. Now coming to the third question, what values of x satisfy the inequality x power 2 by 3 minus x power 1 by 3 minus 6 less than or equal to 0. Now let me consider x power 1 by 3 as 1. Right. Then this inequality becomes y square minus y minus 6 less than or equal to 0. Now we need to find two numbers such that the product of two numbers is minus 6 and sum is minus 1. So I'll write this as y square minus 3y plus 2y minus 6 less than or equal to 0. Now between these two terms I'll take y common. So you'll be having y minus 3. Between these two terms I'll take 2 common. You'll have y minus 3 less than or equal to 0. Now between these two, I can take y minus 3 common, and I can write this as y minus 3 into y plus 2 less than or equal to 0. Now let me plot this in number line. Now let's start with the minimum value. Y plus 2 should be 0. So value of y should be minus 2, and y minus 3 should be 0. That means y is equal to 3. Now to the right side positive, between these two negative, and then positive. Right? So less than or equal to 0. So that should lie in this region where y is minus 2 to 3, and that can be less than or equal to also. Right? You can include minus 2 and 3, because when y is equal to minus 2, that becomes 0. Right? And this could be 0. So we are asked to find the values of x. Now we have the values of y. We have considered x power 1 by 3 is equal to y, or x is equal to y cube. Now if y lies between minus 2 and 3 both included, the value of x lies between minus 8 and 27. Hence option D should be the answer to this question. Now coming to the fourth question, find the number of non-negative integer solutions for xy is equal to 8x minus 10y. Now what I'll do is I'll shift minus 10y to left hand side. So you'll be having xy plus 10y is equal to 8x. Now let me add 80 and subtract 80. Now why am I doing that? Because when I take y common, you will be having x plus 10 here. I can write this as y into x plus 10. Now I also want to have x plus 10 into something on right hand side also, right? So that if I take 8 common, you will be having x plus 10 minus 80. Now let me shift this 80 to minus 80 to left hand side, and this y term to right hand side. So 80 is equal to 8 into x plus 10 minus y into x plus 10. Now between these two terms, let me take x plus 10 common. So x plus 10 into 8 minus y, and this should be 80. And it is also mentioned that both x and y should be non-negative. So you can have x and y taking values from 0 to plus infinite, right? Now, and they should be integers. So x and y should be integers and non-negative. Now let's write 80 as a product of two integers. I can write 80 as 1 into 80, then 2 into 40. Now 3 is not a factor of 80. Then we have 4 into 20, then 5 into 16, and then no, not 7, 8 into 10. Again, you'll be having 10 into 8, 16 into 5, 20 into 4, and so on. Right. So this should be equal to x plus 10 into 8 minus y. See, 8 minus y, the value of 8 minus y has to be 1, because 8 minus y cannot be 80. So the value of x has to be 70 and y 7. Done. Now for that to be 2 into 40, x should be 30 and y has to be 6. 4 into 20, x should be 10 and y has to be 4. 5 into 16, x has to be 6 and y should be 3. 8 into 10, x should be 0 and y should be 0. So you have how many? 5 solutions where x and y are non-negative integers for the given equation. So hence the answer for this question to be 5. Now coming to the last question, if the roots of the equation x square plus px plus q is equal to 0, so we have x square plus px plus q is equal to 0, let the roots be alpha 1 and beta 1. Differ from the roots of the equation x square plus qx plus p is equal to 0 by the same quantity. So we have one more equation x square plus qx plus p is equal to 0. Let the roots be alpha 2 beta 2. It is given that alpha 1 minus beta 1 is equal to alpha 2 minus beta 2, or alpha 1 minus alpha 2 should be equal to beta 1 minus beta 2. I can rewrite in this form. Right. Now how can I have alpha 1 minus beta 1? Alpha 1 plus beta 1, sum of the roots whole square, or let me square on both sides. So I can say that alpha 1 minus beta 1 whole square is equal to alpha 2 minus beta 2 whole square. So I can get alpha 1 minus beta 1 whole square as alpha 1 plus beta 1 minus 4 alpha 1 beta 1. And here you will be having alpha 2 plus beta 2 whole square minus 4 alpha 2 beta 2. Now sum of the roots, minus b by a minus p, so p square minus 4 into c by a 4q. Now this should be equal to q square minus 4p, or what do we have? Let me bring a q square here. P square minus q square is equal to 4 into, you will be having q minus p, right? On sending minus 4q to right hand side. So I'll write this as p minus q into p plus q is equal to 4 into q minus p. So p minus q into minus 1 is q minus p, or p plus q is equal to minus 4. So the answer for this question should be option B.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.